Hey everyone, and welcome. Today we're tackling something that literally all of us have seen, but honestly, very few of us truly understand. We're about to go on this incredible journey in today's explainer, starting from the hard mechanical physics of Earth's atmosphere and traveling all the way out to the sheer poetry of the cosmos. We'll be doing a sort of zoom-in, zoom-out exercise today. So first, we'll zoom way in on the exact nitty-gritty mechanics of what happens to light as it travels through space. And then we're going to zoom back out to appreciate the absolutely breathtaking beauty that it creates right above our heads.
Okay, let's dive right into this. Why do stars twinkle, but planets do not? I mean, almost all of us have looked up at the night sky at some point and noticed those flickering, dancing lights, right? But what's truly fascinating here is that this tiny, seemingly simple visual difference, this little twinkle, actually hides some massive physical truths about our universe. It's not just some random visual quirk, it's actually this incredible story being told to us by sheer astronomical distances.
Which brings us to Section 1. Why do stars twinkle?
So we are officially entering the zoom-in portion of our analysis, focusing purely on the mechanics of space and distance. And this brilliantly illustrates that the answer to our twinkling question lies entirely in distance. See, stars are so incredibly, unfathomably far from us that despite their massive, burning size, the light that actually makes it to Earth arrives as just a single, fragile, incredibly thin point. Planets, on the other hand, they're much, much closer to us here in our own solar system. Because they're closer, their light doesn't arrive as a single vulnerable point, but rather as a broad, thick beam. This raw mechanical difference in how their light travels through the vacuum of space to reach us is the exact reason why the night sky looks the way it does.
Let's look closer at that in Section 2, Atmospheric Refraction and Physics. Now we're going to actively track that single, tiny point of starlight as it finally hits Earth's protective layers. Just imagine that light, traveling for literally millions of years, perfectly straight, completely undisturbed through the vacuum of space, right up until it smacks into the chaotic, swirling gases of our own planet. First, that single point of light enters Earth's atmosphere. But here's the thing, our atmosphere isn't just some static, calm block of air. The light is suddenly forced to push through these chaotic layers of completely varying temperatures and densities. You've got hot air rising, cold air sinking, swirling winds, the whole shebang. Because of all this total chaos, the light bends and refracts continuously. That single point of starlight is essentially getting violently bounced and tossed around by the atmospheric layers before it ever actually hits your eye.
The official technical term for this phenomenon is scintillation. It's basically the constant flickering and refracting of a single point of light as it passes through all those varying atmospheric conditions we just talked about. And hey, remember that broad beam of light from the planets we discussed earlier? Because a planet's light hits us as a thick, broad beam, all those atmospheric bends and shifts, they're easily canceled out across the overall width of the beam. The broad beam effectively neutralizes the flickering effect, and that is exactly why planets shine with this steady, solid glow, while stars fiercely, constantly twinkle.
Now let's shift gears for Section 3, a smile in the sky. Up to this point, we've really been viewing this whole phenomenon through a pretty cold analytical lens of hard science and atmospheric equations, right? But now, it's time to zoom out. Let's shift our tone a bit and look at this exact same physical event not just as an equation, but as a deeply aesthetic experience, one that's literally captivated the human soul for millennia. Consider this much more profound perspective. This twinkle in the sky is a smile and an ornament. The universe is displaying its richness and beauty. The prominent 20th century philosopher and Islamic scholar Said Nursi interpreted this physical twinkling not as some random cold mechanic of physics, but as an aesthetic smile and a beautiful ornament hung in the sky. He noted that it's almost as if the universe is deliberately displaying its richness to us. And when you really think about it, the aesthetic impact of looking up at a starry night leaves this emotional impression that feels far, far beyond just a coincidence of physics.
Moving on to Section 4, the harmony of science and beauty.
So the crucial point is, this is where we finally synthesize the two halves of our analysis. We're left with this dual reality that exists in total magnificent harmony. On one hand, you have a strictly physical mechanical event, atmospheric refraction, scintillation. On the other hand, happening at the exact same time, you have this overwhelming aesthetic experience, the mesmerizing beauty of the starry night. Science perfectly, flawlessly answers the how for us. The vast distances, the light beams, the varying atmospheric temperatures. But the why? Why this rigid physics translates into something that so deeply and universally moves the human heart? Well, that remains a beautiful, open wonder for all of us to ponder. So we are left to ask, why does a strict, unyielding rule of atmospheric physics also function flawlessly as a breathtaking exhibition of beauty? Why are the cold mechanics of the universe and our human appreciation of it so perfectly, inexplicably harmonious? It's a fascinating, open mystery to leave you with today. I highly encourage you, step outside tonight. Look up at that twinkling sky and just take a moment to appreciate both the incredible science and the phenomenal beauty happening right there before your eyes. Thanks so much for going through this explainer with me, and as always, stay curious.